Let's take another look at our animation issue, which is really an acceleration and a deceleration issue. If we go find our robot, go take a look at his animator one more time. Remember, you can see that he's sitting in this run, and eventually he'll start kind of switching back and forth between idle and run, and then finalize in idle after a little while. It does take quite a bit. I think he's almost there, though. Let's see. Is it going to happen soon? Oh, there we go. It's starting to happen. Okay, and he went into idle. Looks like he just stayed in idle that time. So here I've got a player debug window. In fact, let's open up a new one. Let's close this tab again, and we're going to go select the player, right-click on it, or yeah, let's just right-click and hit Properties. This opens up a new window that's kind of like an inspector, but it's locked to the player. I'm going to switch it to debug mode, and we're going to take a look at that horizontal value again. Let's go find just the player script and take a look at that. So we've got the horizontal value right now is a 0. If I go over here and I run to the right, it goes positive, and then it drops down to these insanely small numbers. These E numbers are just the number of zeros before it. It's the exponents. It's a tiny, tiny, tiny number that's still not quite 0. So we've got two options here. One, we could have our animator check to see if it's like less than 0.1 or something in our horizontal, and then have it switch over and maybe switch away from a move. We could have the move variable get set to true only if the horizontal is greater than 0.1, or we can fix this horizontal so that it actually just gets to 0 properly instead of being something that's going slow. The reason that it's never getting to the exact number, or here it looks like it's never going to get to the right number, not just getting there slowly. Oh, there it finally got there. It's really slow. The reason for it is that we're using the Lerp method. And the way that we're using the Lerp method in here is not ideal. It is something that you'll see often. You'll see it in documentation all the time and in a lot of examples. And it's this line right here where we're going from a start value to a desired value, and we're always passing in a small value. We're never passing in a full 1. So here we're going to go from like 0 to 1, and we'll move it a tiny bit, and then we'll move from 0.01 or whatever to 1, and we'll move it a tiny bit more. And then we'd go from like 0.2 to 1 with a tiny bit more, and so on. In fact, let's log this out and see what it looks like so you can get a better understanding of what's happening here. I'm going to put a debug.log, and we'll log out the horizontal value. First, let's add a $sign so we can put in variables. Here, that allows us to do string interpolation. We'll put in the squiggly braces, which allows us to put a parameter in. I'm going to put in the horizontal value. Then I'll put in the desired horizontal value. And then I'll put in the amount that we've moved, which is the time.delta time times the acceleration. So I'm going to copy that, put in more squiggly braces, and paste it in. Add a semicolon to the end. Let's save, go play, and see what we're getting in the log, and see how that value is changing, how it's actually going up. So if we go to the console, I'll clear out my logs. We'll press play. All right, so here we are playing, and you can see my horizontal and my desired are both 0. The delta doesn't really matter because it's not changing yet. So let's move a little bit and see what happens to these values. I'll just move a little bit to the right, and then I'm going to pause almost instantly. All right, so I press to the right and pause. Let's scroll down here and look at the logs. Oh, I've got a lot of logs down here. So you can see here I'm seeing my velocity. The first value here is that current one. That's my horizontal. Let's scroll up to where it was 0. So here's where I started moving. Right here, I was at 0, 0, and then the next frame, I had a desired speed of 5 and moved up to a 0.417. The next frame, I had a desired frame of speed of 5 and moved up to a 1.01. Then I went to a 1.27. That's this, again, this first number before the 5. And I keep going. You can see that number went up, 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 and it kept going up and kept going up. But then it eventually stopped. And it stopped going up probably because I pressed pause, but it was never actually going to get up to 5. And the reason for that is the same reason that it's never going to get down to 0. Let me unpause it and pause again and look at the number now. You see how the number kept dropping smaller and smaller and smaller? It's down into more and more zeros. the amount that it's changing by is also dropping. It's changing by 0.03, where before up here, if I scroll up high enough, you see that it was changing by 0.5, and here's some 0.1 at the first point and 0.8. You can see that the numbers, it's hard to tell initially, but what happens is the numbers keep getting smaller and smaller. The amount that it's changing by to get to that value just keeps dropping. So what we want to do is modify this a little bit so that instead of using Lerp and not getting to the desired value that we have, we're just going to modify the value instead. Lerp is useful if we have a start and an end value and a time, like we do with our moving objects that are moving back and forth. But for this, there's an easier or alternative solution. It just requires a slightly more code to write. Well, let's go open up our code on line 93. I'm going to zoom this out just a little bit. And instead of using the Lerp value or the Lerp method here, I'm going to comment that out. We're going to add in a few lines. First, we'll check to see if we need to accelerate. We'll do that by checking if the desired velocity or desired horizontal is greater than our horizontal. If that's the case, then we're going to add some braces here. And we'll say that the horizontal or underscore horizontal plus equals our acceleration times time dot delta time. Now, if our horizontal gets greater than our desired horizontal, we're just going to snap it to that. So we'll say if the horizontal is greater than desired horizontal, then horizontal equals desired horizontal. Now we'll go down and add an else if statement. So we'll say else if our desired horizontal is less than horizontal, well, then we're going to decelerate, or really it's just kind of slow down from the opposite direction or move towards that opposite direction, depending on what we're going. We're going either towards 0 or maybe towards -5, who knows? So we could be going either way. This is going left or right. So we'll say horizontal minus equals acceleration times time dot delta time. I mean, we know. We'll see when our code's running. That's who knows. But say if horizontal is less than the desired horizontal, then horizontal equals desired horizontal. That'll give us some nice snapping and nice smooth control over our acceleration. Let's go try it out. So we should be able to press play. And now our acceleration should be, I think, really in meters per second or in units per second, how fast we accelerate instead of some semi-arbitrary number. So here we go. I can accelerate and decelerate pretty good. I think that looks and feels just about how I want. The final thing that I want to do, though, is make this character spin around so that he actually faces the correct direction. So let's go back into our update method here and the update sprite and animation. Hit F12, and when we flip the sprite renderer here, let's instead flip the animator's transform. That's that child object that's down in the hierarchy. So I'll say underscore animator dot transform dot rotation. Oops, rotation equals quaternion dot identity if it's going to the right. That's our default. And I'm going to copy line 154 onto 156. And here we'll use quaternion dot Euler, or EULER, and we'll put in a 0 and a 180 to flip it around 180 on the y-axis and a 0 on the z. Now we'll have an animator that flips back and forth. Let's see if that works. Jump back in, press play one more time. We should be able to run back and forth, have our character animate properly, and look pretty cool, I think. Let's see. So he runs to the left, runs to the right. I can jump. Everything is looking pretty good. Now, one thing to note is that when I turn, the turning happens visually when the character actually starts moving. If we want, we can also just tie in our animation part here to the input instead. We could tie directly into the input, and it might feel a little snappier, even though it's not actually moving yet. We can also just turn up the acceleration though. So if we want to make this a lot tighter of a feel, turn that up to like a 50, and now we accelerate at about 50 units. Yeah, I feel like that's probably a little too fast. How about a 25? Yeah, I'm thinking I might go with like about a 25 now on my ground acceleration. So I'm going to stop playing, set that to 25. I'm going to override my prefabs, just hit apply all, go save my scene, go into plastic, and we'll check in our changes. The player animates properly now. Or animates move and jump. Let's hit that. Move and jump and faces the correct direction. And I'll check that in.